Hello everyone, this is Professor Amit Solanki. Now today we will solve some numerical problems related to the DC motor drives, a single phase control converter for DC motor drives. So let us start the numerical problems. So first we will take problem number 1. The problem is that a separately excited DC motor has the following parameters, which is Ra means armature resistance is 0.25 ohm, Ke that is a constant 0.62 volt per RPM, Weber, and flux per pole that is the 175 milliweber. The motor speed is controlled by a single phase full wave bridge rectifier, and firing angle alpha is set at 45 degree, and the average speed is 1300 RPM. The applied AC voltage to the bridge is 230 volt at 50 Hz, assuming the motor current is continuous. Calculate the armature current drawn by the motor and the steady state torque for the case of fully controlled bridge and half controller semi-controlled bridge. Now you can see here in this problem we should have to find out the armature current drawn by the motor and the steady state torque for the fully controlled bridge and half controlled bridge. So let us solve this numerical step by step. So let us do the solution. So for that we have find out for two parameters, fully controlled and for half controlled. First we will solve for the fully controlled bridge with continuous current operation. So let us write first formula, that is the average output voltage, that is the 2 Vm by pi cos alpha. So as you know that Vm means root 2 into 230, so that will be 325 into 2 volt. Now put this value in this above equation, that is a 2 Vm by pi cos alpha. Now we will get, if we are putting this value in this equation, so we will get, that is a 2 into 325 divided by pi into cos 45. Cos 45 means alpha, that is the firing angle is given also here. So we will get 146.44 volt. So this is the average output voltage. Now we will find out the EMF armature EMF equations, that is the K EA is equals to Ke phi N. Okay, so put this value in this equation according to parameters we have given. K is 0.62 into 175 into 10 to the power minus 3 into 1300, and that is the speed in RPM. Small end, it is the speed in RPM. Okay. So then we will solve and find out the 141.5 volt. Okay. Now we are getting the next equation, that is a V of T, the terminal voltage or armature voltage is equals to EA plus IA RA. So in that we should have to find out the current, armature current. So for that, from this equation we can get the formula for the armature current, and this will be IA is equals to VA minus EA upon RA. Now put this value in this equation. So VA is equals to 146.44. This will be comes from this equation. EA is the 141.05 and RA is the 0.25 is given in numerical problem. So according to that we can get the 21.56 ampere. So this is the concept formula for the armature current. Okay, so as it is we can do that. So therefore, since deflecting torque, that is the K of T IA phi, where K of T is a torque constant, it is given by 9.55, K is equals to 9.55. into 0.62. So is equals to 6.2. So according to that, we can put this value and find out the value of deflecting torque, which will be 23.4 Newton meter. So these are the all about the concept for fully controlled rectifier. Now we will find out the value for the half controlled or semi-controlled bridge. So before that solving, we should have to know that the formula for half control or semi-converter, that will be Vm by pi into 1 plus cos alpha. Now put this value in this formula and we will get the average output voltage for the semi-converter. Finally, we will get the value of average output voltage for semi-converter is 176.78 volt. Now again next equation, that is EA is equal to KE phi n. Also put the value and we will find out the value of EA, that is the 141.05 volt. Now as it is from previous solution, terminal voltage or armature voltage, there is EA plus IA RA. So according to that, we can find out the value of armature current. For that, we are getting the formula from armature current, that is the VA minus EA upon RA. So that is it is equals to the 142.95 ampere. So according to that, we can put this value of deflecting torque and find out the value of deflecting torque, that is the 155.1. Okay, so this is the all about the concept for the numerical problem of fully controlled converter fed DC motor drive. Okay. Okay, so this is the numerical problem. For that, we have find the value. Okay, so this is the all about the concept of this numerical problem. Now we will take second problem. The second problem is that a single phase full converter of given in this figure is used to control the speed of a small separately excited DC motor rated at 7.5 kilowatt, 230 volt, 1500 RPM, and the converter is connected to a single phase 230 volt 50 hertz supply. The armature resistance is R of A is equal to 0.50 ohm, and the armature circuit inductance is LA is equal to 10 millihenry, and the motor voltage constant is K phi is equal to 0.07 volt per RPM. With the converter operates as a rectifier, and the DC motor runs at 1200 RPM and carries an armature current of 35 ampere. And assume that the motor current is continuous. So you should have to determine the firing angle alpha, power delivered to the motor, and the power factor of the supply. Okay, so this is the numerical problem. So let us solve step by step. So in that numerical problem, what we required, what we should have to find, we should have to find out the value of firing angle alpha, power delivered to the motor, and power factor of the supply. So this is the solution. We will solve step by step. The back EMF of the motor at 1200 RPM, that is the equals to K phi n. Now put the value of parameter in this equation. Now we get the EA is equals to 84 volt. Now we will get the armature voltage. So VA is equals to EA plus IA RA. Now we will put the value of EA and IARA, and we are getting the value of armature voltage, that is the 101.5 volt. So for the full wave rectifier, as you know that the formula for full wave rectifier of output voltage, that is the 2 Vm by pi cos alpha. You can put this value in this formula and find out the value for the average output voltage. But in that case, we have already known the average output voltage, but we should have to require the firing angle alpha. According to that, we can manage it and find out the value of alpha, that is the cos alpha. So we are getting the value of alpha, that is a 60.65 degree. Now we will find out the power, average power P is equals to V into I. So we can put the value of V average and IA average. Now we are getting the value of power, that will be 3552.5 watt. Now next point, that is the supply current has a square wave with amplitude of 35 ampere as shown in the figure. So we will find out the current IS is equals to under root of 1 upon pi integration of 0 to pi IA square d omega t is equals to IA is equals to 335 ampere. So this is the all about the concept for the solution of this numerical. Now we will find out the power factor. Power factor is known that active power upon apparent power. So we can put this value in this equations. Our formula, we are getting the power factor, that will be 0.441. Right. So these are the all about the concept and solution for the numerical problem. Thank you so much for watching this video.